Good morning, students. Dear students, as in the previous video, we had discussed about free body diagram, and in the discussion with free body diagram, we had discussed about the numericals based on free body diagram. In that, we had solved three numericals here, and one numerical I had given to do by yourself in the home. Now, today we are going to discuss one of the most interesting topic, that is friction. So, let us discuss about the friction in today's video lecture. Friction. Yes, students, you had already heard about the friction from very beginning of the study of physics, that is from class 9th. And in class 9th you had studied that if frictional force is that type of force which opposes the motion of the object moving in the straight line or any body moving on the rough surface, then a force that opposes the motion of the object is called as frictional force. So the same thing is here. We can say that when an object moves over any rough surface, then an opposing force that tries to stop the motion of the object is called as frictional force. That force is called as frictional force, the opposing force which acts on the rough surface when the object is in motion. That force, that opposing force, is called as the frictional force, and this process is called as friction. This process is called as friction. The process of application of frictional force on the body when the body moves on the rough surface, then that opposing force is called as frictional force, and the whole process is called as friction, and it acts parallel to the surface. It always acts parallel to the surface. Parallel to the, it always acts parallel to the surface. Here I want to explain the basic concept, the microscopic concept behind the frictional force. You had already studied in class 9th also. When we view the surface of any rough object, then it looks like this. It looks like this. Certain ups and certain downs are observed on that rough surface, and suppose any object whose surface is also rough is placed over this surface, this is the object and this is a rough surface. This is a rough surface and this is the rough surface and this is object. Now look at here. In this there is a hookwork contact, means the down of the object is being captured by the up of the surface, means this thing going to happen. A blocking, that is called as the blocking. A blocking is developed between the object and the surface. Now suppose to move the object over this surface, a force is being applied over the object. Over this object a force is being applied, and when the force is being applied, then what will happen? This force is translated on each and every particle of this rigid body, means this force is being acted over here also, and if this force is acted over here also, then it pushes this part, the uplifted part of the surface, and due to Newton's third law, a opposite force, due to every action has equal and opposite reaction, opposite reaction. So if force F is being applied on this surface, then a frictional force just opposite to this, which tends to counterbalance the applied force, such that the body follows the law of inertia or the body maintains its state. So a frictional force is being applied over here, and this frictional force, this is the cause of the development of friction or frictional force over the surface. So this is the microscopic concept. I hope you had understood this. So this is about friction and this is the frictional force. Now suppose this is a body, and a force is applied in this direction, and this is the direction of motion. This is the direction of motion. Then a frictional force is being applied. In opposite direction. This is called as frictional force. Similarly, if it is the rough surface and if this is the direction of motion, this is the direction of motion, means the force is applied here, since force is applied in this direction, so this is the direction of motion. Then a frictional force F is being acted over the object in the opposite direction. A frictional force is being acted over the object in opposite direction. So we can say that if we give a gentle push to the block slides through a small distance and comes to rest. If we apply gentle push or if force is applied, the block moves to a small distance and then comes to a rest. Then, according to Newton's second law, a retarding force must be acting on the block. This retarding force or opposing force is called as friction or frictional force. It always acts tangential to the surface in contact, and in the direction it is opposite to the direction of motion, relative motion between the object and the surface. It acts opposite to the relative motion of the object and the surface, and its it acts in opposite direction to the applied force or the direction of motion of the object. Suppose the direction of motion is in this direction and force is applied in this direction, then frictional force is applied in. Frictional force is generated, not applied, because frictional force is self-adjusting force. It adjusts itself due to the application of force which I had told here. Clear, students? So this is about the friction, this is about frictional force, this is the microscopic concept for the application of frictional force on the object, how it is generated. So this is about friction. Now we will discuss about the types of friction. We will discuss about the types of friction. Dear students, while discussing types of friction, there are different types of friction, but according to the frictional force between two objects or two bodies, the friction is broadly classified into two categories. The first one is internal friction. Internal friction. The first one is internal friction. Now, dear students, what is internal friction? I will define it also. First of all, understand what is internal friction. Suppose here, this is a tube, and in this tube, liquid layers are flowing. These are the layers of the liquid, and the liquid layers are flowing inside the tube. Then there is an opposition between two layers. Suppose the particles of this layer and the particle of this layer are coming in contact, then it will tend to move downward. To balance this downward force, a force is acting in upward direction. This is also a type of force. This is also a type of frictional force. But this frictional force acts due to the internal molecules of the fluid flowing together. Suppose wind is blowing, then the particles of the wind are going to be in contact with each other, and due to the contact of the wind particles, wind molecules, there is an opposing force in the opposite direction of the motion of the particles, and this frictional force is called as viscosity. This is called as viscosity, which we will study quite in detail in the chapter fluid mechanics. So internal friction arises on account of relative motion between the two layers of the liquid. It arises due to the relative motion between the layers of the liquid, or you can say that fluid. Anything which can flow is called as fluid. So this is internal friction is referred as it is referred as viscosity. About viscosity, we will study quite in detail in the chapter fluid mechanics. So this is about internal friction, and internal friction is due to the opposing force between the layers of the fluid. Now we will discuss about the another type of friction, that is called as the external friction. Next discussion is external friction. external friction. Second one is external friction. External friction is nothing. It arises when the two bodies in contact with each other try to move, or there is actual relative motion between the bodies. Suppose this is a rough surface. This is a rough surface, and this is rough surface. This is rough surface, and this is the block. This is a block placed over this rough surface. Now what will happen? If force F is being applied over this block, then what will happen? Automatically, a force which opposes the motion of the, if we are going to apply the force, suddenly a force starts acting in the opposite direction parallel to the, suddenly a force starts acting parallel to the surface as the force applied. It does not matter that the body starts moving or not. If the body is not moving, in spite of that, if you are applying the force for the movement of the body, then a opposing force F is being applied over the surface parallel to the surface in opposite direction of the applied force. And this is the force generated externally. This force is not in the system of the surface or this block. This is an external force. So the frictional force which generated in this type of system, in which the force is not inside the body, inside the block or the rough surface, is called as external friction. So this type of force is generated due to the body tends to move over the surface or starts moving over the surface. So this type of friction is called as static friction. This external friction is called as contact friction. This is also called as contact friction. This is also called as contact friction. Now there are various types of external friction. External friction are of various types. The first one is static friction. Then the second one is kinetic friction. Third one is sliding friction and rolling friction. So we will study one by one. So first of all, we will study about the static friction and try to understand the properties of the static friction. So the first part of the external friction is static friction. The first part is static friction. External friction, the first part is static friction. It is generally denoted by Fs. It is generally denoted by Fx. Fs, F suffix S, and it is called as static friction. So this is the surface, and look at here. The static friction is that friction in which the body is not moving, but we had applied the force for the movement of the body. We had applied a force for the movement of the body, and the body had not started moving at all. But as we had applied force, then by Newton's second law and Newton's third law, a force in the opposite direction parallel to the surface starts acting for the opposing the motion of the object, but the body is not moving, not started moving. So as the force is applied, a frictional force acts in the opposite direction for the applied force, and this is called as Fs, that is called static friction. So write it down. Force of friction which comes into play between the two bodies. Force of friction which comes into play when two bodies in contact, not actually it starts moving but tending to move. They are not actually moving, but they are intending themselves to move. So it is denoted by Fs. That force of friction is denoted by Fs. This static friction opposes the impending motion. This static friction opposes the impending Yes, students, it is obvious or quite clear to you that whatever the motion the force F tries to do in the body of mass m, that motion is being obstructed by the frictional force Fs. That motion is being obstructed by the frictional force Fs, that is the static friction. So the static friction always opposes the impending motion. Means if this friction is not being here, or if the surface is smooth, then body starts moving in this direction. But due to the roughness of the surface, or due to the Fs, static friction, the body had not started moving. It required more force for the movement over the surface. So we can say that the static friction opposes the impending motion. Clear, students? If there is no force, then there is no static friction. So Fs is a self-adjusting Fs is, that is static friction, is self-adjusting in nature. According to the force, it adjusts itself. So it is called as self-adjusting nature. That static friction is self-adjusting nature. Now students, we will discuss about the second type of friction. This is static friction. First type of external friction, that is static friction. Now the second type of friction, that is limiting friction, we will discuss.